the algorithms related to page replacement and those which are actually used to decide which page we want to throw out from memory when we run out of space. So in the previous segment, we looked at how to perform page replacement. Now we're going to be looking at which page to choose. So it's closely related to performance, and we're going to care about if we having something that's important. Right? So there are lots of different algorithms. The ones that are used, OPT is our baseline. So this is the one that we will compare against. So all algorithms will be compared against OPT because it's theoretically provable you cannot do better than OPT. So this is our baseline. Okay. The ones used by Linux are a version of the clock algorithm and the working set clock algorithm. Okay. Working set is not really a page replacement algorithm. It's got more to do with how to estimate how many pages a given process needs. That is, if you give it more space, will it improve in performance? And so we'll look at both replacement and working set, which mainly looks at allocation. How much space do we want to allocate? All right, so the two different parts. So let's talk about OPT replacement first. So in general, the idea behind OPT is we want to replace the page that won't be used for the longest time. So it assumes that you know the future. It assumes it's infeasible in practice because you don't really know the future. But essentially, let's say at any given time that you want to look at which page to replace. In this case, you look far ahead and you see which is the page that's accessed the furthest along that time. So time moves left to right in this figure. So let's say that was page A. Then our candidate at time small t less than t would be A. So at the point of small t, which is far less than the furthest away from the future, we look at which one is used, and that's the candidate we choose for replacement. It's a good baseline because you cannot do better.